Okay, why is science important in early childhood? What we're going to teach when we teach science with young children is really about how to think, right? How to think about things, how to discover, how to inquire. This is how we're going to talk about science in young children. So, research shows that kids love learning about nature and exploring the world around them. Makes sense. They're in early childhood, they're starting to learn that there is a world around them, that it's not just themselves that are the most important things. So this is a time of discovering about, outside you. Um, Early science learning provides a solid foundation for development of future science concepts. Throughout this semester, one of the things that I want you to learn is that it's important to introduce kids to these concepts at this age, but what we're not doing is trying to get them to understand how chemistry works or what biology is or algebra or multiplication. What we're doing is we're introducing these ideas so that later on in first, second grade, when they start talking about these things, when they start talking about photosynthesis or whatever, they have this already sort of foundation that they've gotten in preschool, early childhood. So we're not trying to teach them the concepts at this point. We're introducing it so that it can be a foundation, a basis for later learning. Engaging science experiences allow for development of scientific thinking. Like I said, a lot of what we're doing is teaching kids how to think, and not necessarily about specific concepts, but how to understand things. And science thinking skills transfer to other academic domains. If you take CHD 124 program planning, you learn a lot about the project approach. And the project approach, which is a way to teach children about specific topics, about themes, about investigation. So the project approach is really based on the scientific method, which we'll talk about in a little bit. Um, we've spent a lot of time talking about science, STEM, science, technology, engineering, and math in education over the past 15, 20 years, right? So, what has happened is because of the focus on science, everybody's getting a lot of science. We spend a lot of time on it. So, the achievement gap, the difference between what children from a higher socioeconomic status, what their achievement is in science as opposed to a lower socioeconomic status, that achievement gap is closing in math or in science. So it's narrowed. It hasn't closed, and it hasn't. We haven't completely resolved achievement gaps, but because we focused on it so much, it's not as wide as it used to be. So achievement gaps are evident at the very start of school. Gaps in enrollment for science courses, college majors, and career choices also persist across racial, ethnic groups, socioeconomic status, and gender, right? My daughters talk about how constantly, when they were in middle school and high school, teachers were talking about girls in STEM, girls in STEM, girls in STEM. And because when I was going to school, there wasn't this focus on girls doing math and science. It was more that's kind of the boys area, and so girls, you should learn English and art and that kind of stuff, and don't worry so much about science. I mean, it was never said that way, but it was kind of an implicit focus. And so the idea that we talk about girls in STEM, girls in science, girls in math, girls in engineering all the time, girls in computers, has made it not as much of a big deal, but it also, I think kids, my girls are like, why do we have to talk about that all the time? I don't really like math. It's not that I've felt like I've been discouraged from doing math. It's just not my thing. Scholars have linked early difficulties in school science with students' decisions to not pursue advanced degrees and careers in science, right? So if you aren't interested or you have trouble with science early on when you're in third grade, you're going to be less likely to study science when you go to college, or when you're in high school, you're not going to take those advanced classes. And we need more scientists, we need more engineers. So it's important that we set the stage and that we make it fun and interesting in early childhood, so that they don't have that resentment and that, like, ugh, I don't really like math later on, or science. Young children's early understanding of science is deeply rooted in daily experiences. Talking about the weather every day is a way to get kids interested in science. Talking about, the water in the water table, or how sand works, or whatever, having them have those daily experiences with science helps them understand. um, Self-centered or human-centered, right? We know at the age of preschoolers that they have an understanding of the way the world works that is deeply rooted in how they work and their personal experiences. So they're not going to really understand how the moon works in the way that is scientifically appropriate. But if they're thinking about it and how it relates to them, then they are making that step toward understanding science. Focus on change, not constant. Well, when you want to teach about science for early childhood, you want to talk about how things change, right? You're talking about how a caterpillar goes into a cocoon and becomes a butterfly. You're talking about how seeds get water and sun and they grow. So that's how you want to be focusing on science in early childhood, is how things change over time. Concepts and definitions may be broader or different than adults. They may not understand that plants are alive because they don't move. So you need to talk about how we know a plant is alive, what makes us know that things are growing, right? They don't get that, like, um, you know, for them, alive means movement. Okay. What is next? They need engaging science experiences, like they need engaging music experiences, engaging language experiences, engaging math experiences, engaging art experiences. The whole thing with early childhood with young children is it needs to be something that they can put their whole bodies into, that they are interested in, that they can focus on. So you need to be developmentally appropriate. Start where children are and scaffold. So what is a seed? How does it work? How can we add on more information as we go? Teacher responses that encourage exploration, planning, and guided inquiry. So not giving them the answers when they ask a question, having them help you find the answers to the question. Why does snow melt? Well, let's figure that out. How can we find the answer to that question? What do we need to do to figure that out? Real world experiences, like I said, anything that they can touch, they can see in front of their faces, is going to make more of an impression than you just telling them. Using appropriate vocabulary to describe science concepts, explaining in words that they will understand what the science concepts are. Dissolve, melt, photosynthesis, float, sink. Those are all words that are scientific concepts that you want to help them understand. Um, Culturally responsive, build on children's experiences. Think about where they live, what they see, what they understand in their lives. Making it hands-on, small groups, sense-making discussions, sciencing. We're sciencing today. What are we doing? We're sciencing. So, when you're doing things with in your sand and water table, or you're digging outside in the dirt and you're finding worms, talk about that as science. We're sciencing. And focus on exploration, not the right answer. What's going to happen is you may have an idea of how an activity is going to work, but it may go off the rails because they have another understanding, right? So anytime that somebody comes up with a new idea or a different idea than what you started with is fantastic. You're exploring, you're discovering, you're coming up with new ideas together. It's not all about getting from point A to point B. When you're sciencing, it's what's happening during the process, like with all early childhood learning experiences. It's about the process, not the product. Early science concepts that you're going to talk about and tackle with your kids, the scientific method, which we'll talk about in just a minute. Physical properties, force, motion, ramps, what balls, things that move, how we talk about things that move, fast and slow, right? Bumpy. These are all physical properties that are, when you are learning to describe things using their physical properties, you're learning how to talk scientifically. The earth, talking about the earth, the environment, weather, space, life, your body, how things are changing and growing. What do you need to grow? What does a plant need to grow? And engineering and technology, investigation and tools, microscopes, magnifying glasses, measuring tapes. These are all parts of science and engineering and technology in early childhood. This is the National Science Teachers Association position statement on early childhood science education. Basically, they say everything that we just talked about, but it's boiled down into their position statement. And it is that you need to engage and nurture curiosity and provide experiences that are going to help them understand, make them want to learn more, and provide a good foundation, a positive foundation for future science learning. Okay. Scientific method in early childhood. So the scientific method is basically ask a question, do some research, construct a hypothesis, which is a possible explanation about why something occurs, conduct an experiment or many to make intentional observations that test the hypothesis to try to show if it is right or wrong, analyze the data that you collected, draw a conclusion, and then communicate the results that you have developed through your observation and experimentation. Okay. So the scientific method we use all the time, whether we know it or not. And this is how we conduct scientific research, even in college, in labs, right? And we're going to teach preschoolers how to do it. So this is some cute little graphics that we can use to talk about the scientific method with preschoolers. So the first part is the observation of the question. I wonder why seeds grow. I wonder why the trees are getting leaves, right? I wonder what's happening. So then I ask a question. Why are the trees growing? Why are the flowers blooming? What's happening, right? And then I think it's because the seeds are growing, the sun is shining, the water, the rain is, right? I think these are the things that are making the seeds grow. So then I conduct my own experiment. I take seeds, I put it in a, you've all seen this one, you put it in a baggie with a paper towel and hang it up in the sunshine, right? And bean sprouts will grow. So what do we know? So we might do that with without the paper towel, right? Without the wet paper towel. We might do it in a dark place so that we can compare what happened and draw conclusions. So conducting my experiment, and then I learned that the one with the paper towel, the wet paper towel in the sunshine grew, the one in the dark didn't grow, the one that didn't have a wet paper towel didn't grow. So I think seeds need sunshine and water in order to grow. And then I can record my results and share it, right? So this is how you do a scientific experiment in grade school. Now let's watch a little video.
Welcome to this short module on using the scientific method. The purpose of this module is to identify and describe the steps of the scientific method and to help you think about how you can incorporate these steps into your interactions with children. Using the scientific method fits into the foundation of our house framework. These foundational practices represent one component of quality teaching and learning. All the components are essential for quality teaching and learning and school readiness for all children. The foundation highlights the engaging environments and interactions that are so important for children's social and academic development. The scientific method is a series of steps that help children expand and extend their knowledge of the world around them. Of course, scientists use the scientific method, so do teachers, and so do children. What are the steps? Question, observe, predict, experiment, and discuss. Those are the steps, but they don't need to occur in that order. Let's see how it works. Teachers encourage children to form questions about the world around them. Children are curious. They want to figure things out. Teachers plan enticing activities and also take advantage of natural phenomena. Teachers give children time to express their questions. And teachers notice children's interest and model asking a few questions of their own. Observing is how children gather information to answer their questions, to learn more about something, or to figure out how to solve a problem. Teachers encourage children to notice details, to compare, and to use all their senses.
Magnifying glass. When I look in it, it kind of looks like a different color. Oh, good observation. So Zeke's going to shake it and see what he sees.
This is where those open-ended questions come in really handy. So you need to be asking kids what's happening, not telling them what's happening, right? So if you see these kids have bottles and it looks like they may be mixing colors of water or something, you need to be asking, what do you think is happening? Why do you think it's happening? What did you do? What's going on? Okay.
To predict is to describe what you expect will happen. Predicting is a little bit like guessing, but it involves more sophisticated thinking because predictions are based on knowledge and observations. To predict, children try to think about what happened in similar previous situations and then imagine what might happen in the current situation. Teachers encourage prediction by asking questions, giving children time to think and answer, and participating along with the children in the problem or experiment.
If a polar bear is in ice water, and if your hand's in here, covered with the blubber, what do you predict will happen? What do you think will happen? Do you think your hand will be cold or it will be warm? Warm. Let's try.
So prediction, what you need to do is not only ask what's going to happen, but have them tell you why they think that, right? Because that helps them understand the way they think. And while this is a really like abstract concept for a 3-year-old to understand, it is important to sort of set that stage. So when the little girl, so what they were doing was putting like Crisco on their hands, and saying it was like blubber. And when they put their hand in the water, then it won't be cold, to talk about polar bears and how polar bears stay warm. So her next question to the little girl said, I think my hand will be warm. Why do you think that? So she needs to go back in her head and think about what is the research or what is the cause for you to think that. And it may be that they read a book, or it may be I've done this before, or it may be, something, but have them investigate their own thinking. Why do you think that? Why do you predict that this golf ball is going to sink when I put it in the water? Well, because it's heavy, or because it is, plastic or whatever, because that also then helps them understand why or why not it did or did not happen. This is like higher level thinking for preschoolers, and they don't have to get it, but having them begin the process and get in the habit of investigating their own thinking is important.
After the child makes a prediction, the teacher provides opportunities to test it out. If necessary, the teacher also encourages the child by saying, "Let's see," or "Let's try it." The teacher can guide children to observe the results. Was their prediction accurate? What's the evidence? Should we think about this some more?
You were saying you thought if we mixed red and orange together, it would make purple. So let's find out what happens if we mix red and orange together.
And so, children and teachers discuss and talk about the results. Children and teachers share their questions, observations, predictions, and conclusions with others. Children can communicate their ideas by talking and also by drawing or demonstrating what they observe.
Wow, tell me about how you made that color.
And this and this and this and this and this.
So you mixed all of the colors, and what did it make? Sure. Blackish brown, right? Wow, you are being a scientist and making different colors with your paints today.
The scientific method can be used across the areas or domains of learning in all kinds of places. It might seem like the scientific method requires fancy experiments, but there are all sorts of opportunities that teachers plan for and take advantage of. So let's look at a few.
What is inside of there? Seeds.
What do you think is making them so happy?
The water.
They're talking, they may be talking and having fun. And the water, how do you think they say? Everybody show me how you hibernate. Pretend you're a bear and hibernate. Yeah. Yeah, hibernate.
This module highlighted the scientific method and gave a few examples of how teachers might use this method in their classrooms to expand their children's thinking and understanding. Using the scientific method takes some practice and planning, but it's exciting to watch and listen to the children as they use these skills. Check out our tips, tools, and resources. Thank you for listening and have fun with the scientific method.
So when you think about doing science with young children, it should be as much about teaching them to do scientific thinking as about the concepts that you're teaching them. You want to encourage a sense of discovery, exploration, asking questions, analyzing, trying to figure out how things work. That should really be the focus. There are, of course, concepts that you will want to teach, but really focusing on how am I thinking? How am I understanding? How can I learn more about this? Yep.
What is it going to eat?
A grape.
Okay, so draw the grapes in there. So far, he's not moving. Jake didn't move yet. I wonder what's wrong with Jake. I wonder why Jake's not moving. We're drawing a picture of the hermit crabs, all right, and how they eat their food. So we have to observe to see what they do first. All right, Bailey, are you drawing yours? He's going on the grape. Let's see. Is he eating the grape?
No.
Oh, he moved away. He moved away.
No.
Maybe he's not hungry. Are those the grapes too?
I'm making a crab. I got chin.
Tell me, the crab has a chin.
I need a grape.
Can I write your name in your paper? And I want you to tell me.
I need a grape.
I want you to tell me.
A grape.
No, that one we cannot eat, okay? Because my hands were on it and now it's dirty. So we need to get fresh, clean grapes. So Bailey, I want you to tell me.
It's cold.
I want you to tell me
It's cold.
what you. It was in the refrigerator. That's why it's cold.
It's a big one.
It's not eating though. Do you think it's hungry?
No.
Maybe it's not hungry.
It's moving.
Okay, good.
Why be calm, baby?
Probably because what? Oh, we need to be calm.
Ow.
Okay. Bailey, tell me what to write.
Ow.
What did you draw here, Bailey? What is the hermit crab doing? What did you see it do?
Look beside the big purple.
What is it going to?
So those kids seem to be like young threes, and they're learning, they're sciencing, right? She's asking them questions that are prompting them to observe and make predictions. Even though it doesn't seem like science, that's what it is. There are a couple other examples. I'm not going to share them here, but they're on Cobra for you to look at. And that is it. So happy sciencing.